This video is about how the astronomical distances we're going to use to measure the distance to things in space, and also how we measure those things in space. Probably the unit that you've already heard of is called the light year, and we write it LY to abbreviate it. It's a great way to measure distances because the speed of light is a good constant all over the universe, independent of how fast an object is moving. It's defined as the distance light travels in 1 year, and it's important to remember that it's not a unit of time, it is a unit of distance. 1 light year is equal to 9.46 times 10 to the 15th meters. Another important unit that we're going to use is the astronomical unit. It's the average distance between the Earth and the Sun. So it's defined as, let me get my pen out. It's defined as, so if this is the Sun and this is the Earth, as the Earth orbits around the Sun in a roughly circular orbit, the average distance between the Earth and the Sun is 1 astronomical unit. It's equal to 1.5 times 10 to the 8th, or 10 to the 11th meters, and it's equivalent to about 8 light minutes. So that means light from the Sun takes about 8 minutes to get to Earth, or to cover this distance of 1 astronomical unit. The last unit we're going to be using to measure distances in space is the parsec. It's the most commonly used unit of distance in astrophysics, and 1 parsec is equal to 3.26 light years, or 3.09 times 10 to the 16th meters. Okay. In order to measure distances in space, we have to do something special because we can't directly measure the distances because they're much too long to directly measure. So we need to measure them indirectly, and we use something called parallax, or stellar parallax. So if I were to draw the Earth, or let's start with it. So if I were to draw the Sun and the Earth orbiting the Sun, the Earth would take 1 year to go around this orbit. So if I start here, 1 year later, I will have returned to the same place. So that means 6 months from the time I'm here, I'm on the other side of the Sun. This has an interesting consequence. So if I were observing an object, like a star, out here, I would be observing it from this angle when the Earth is in this position, and I would be observing it from this angle 6 months later. And if we were to divide this triangle that we've created in half, we can actually measure this distance from the star we're observing from Earth to the Sun using just a little bit of math. So we know that the distance from the Earth to the Sun is 1 astronomical unit, and so both of these distances are about 1 astronomical unit, and so this whole thing is equal to 2 astronomical units across if we were to combine this whole segment. We can take the angle, we'll call it angle P in this case, or for parallax angle, and using the equation d for distance is equal to 1 over the parallax angle we can compute this distance. And so the parallax angle is measured in what we call arc seconds. And the distance we'll get is going to be in parsecs. An arc second is 1/3600th of a degree. Okay.